Welcome you to Do Magic with Maths. Before we start today's lecture, let's recall what we did in our last lecture. Okay, so let's do the quick revision. In the last lecture, we discussed about the different properties. Properties like the first one was closure. Then the second one was commutative. And the third one, that was associative. We checked for different operations like addition, subtraction, multiplication and the division. For example, closure, it means suppose I just select any two numbers from the natural numbers like 2 and 3. And if I do the operation of addition, what answer I will get? That will be the 5. That will be the 5. So we have to check that 5 is natural number or not, because these both are natural number. If this is the natural number, it means natural number is closer under the addition. Yes, that is positive. So it means natural number is closer under the addition. Same for the commutative. In commutative, what we will do? We will shuffle the number, and if answer is same, it means that is the commutative. Like 2 plus 3, that is 5. As well as I will just shuffle this number. So 3 plus 2, answer will be same, that's the 5. It means natural number is commutative under addition. And the last one was the associative. In associative, we were just making the groups of the numbers. Like if I select three numbers, 2 plus 3 plus 4, here I have to select the group. Okay. So how I will do? I will first of all solve this bracket. So 2 plus 3, that is the 5, plus 4, that is 9. Okay. Now again I have to change the group for that. So it means 2 plus 3 plus 4, 2 plus, solve the bracket first. So that is 7. 7 plus 2, that is 9. Here we got the same answer for both the way. It means natural number is associative under the addition. Okay, so this is all about the different properties which we have already discussed in our last lecture. Today we are going to discuss about the role of 0 and 1. Before that, just pause the video, note this down and revise what we did in our last lecture. Now we will see distributive property of multiplication over the addition. So the question is, what is the distributive property? Okay, it's very simple. We will just understand by an example. Suppose I have 2 multiplied by 3 plus 5. So here it means that distributive property of multiplication, because we will distribute this. Okay, so distributive property of multiplication over the addition. First of all, we will solve this by a very simple method, and then we will actually use the distributivity for this problem. Here we have 2 multiplied by 3 plus 5. So very simple. That the 2 multiplied by 3 plus 5 is, because we always solve the bracket first. 3 plus 5, that is 8. That is 8. Answer 2 8s are 16. 2 8s are 16. That's the answer. Now in the next step we will solve by this property, and we will check that answers for the both are same or not. Okay, so again I am going to use this same problems. Now distributive property says that if here is a multiplication, it means this number 2 will multiply to 3 as well as multiply to 5, both the numbers. How? First of all, I will just multiply with the 3 because that's the first one. So 2 multiply by 3. 2 multiply by 3. Which side is here? Addition, so put that. Again, 2 multiply by 5. 2 multiply by 5 like this. Once again, 2 will multiply to 3 first, then 2 will multiply to 5. And in between, there is addition sign, as it is here. Okay. So, now just do the multiplication. 2 3s are 6. Addition sign as it is. 2 5s are 10. 6 plus 10, that is 16. Now just check that For both the methods, answer are same or no? Yes, that is 16 and 16. So this is how we can use the distributive property. Here I use this for the natural numbers or for the whole numbers. Pause the video and note this down. For distributivity, we can say that if suppose A multiplied by B plus C is there, A multiplied by B plus C is there, it means for the equal we can write that A into B. So it means A into B plus as it is A into C. So that is A into C. Okay. Here is addition. Suppose there is subtraction. At that time, what will happen? If I just write like this, A multiplied by B minus C. So it will be A into B, and here is subtraction. So just put the subtraction. Here there was addition. So we just keep addition. Now subtraction. A into C as it is. This is how we can do the distribution. Okay. So just pause the video, note this down. After the exercise 2.1, okay, as we have seen the different properties for the whole numbers, okay. First of all, we have seen for the natural numbers, and from that we can just simply identify for the whole numbers, because there is no most difference. There is a very slight line, that is 0. Okay, and the properties are almost same for natural number as well as the whole number. Now the next topic, that is identity for the addition and for the multiplication. Now the question arises that what is the identity? Especially in the identity of addition and multiplication, it means that if we do the addition operation, if we do the sum of any two numbers, and if there is no change, like if suppose I just do 5 plus something, and if answer is 5 only, it means whatever the something, which the number which we add in the 5, that is mathematical identity. Sorry, additive identity. But let's see how we can do that. Suppose 5 plus something is 5. Okay. Is this possible? 5 plus 1, that is 6. 5 plus 7, that is 12. Okay. Here is only one possibility, that is 5 plus 0. 5 plus 0 is 5. Okay. So like that, if I just do 13 plus 0, that is again 13. Like 1, 7 to 9 plus 0, that will be 1, 7 to 9. So we have a number in the maths, okay, that is 0, which we add in any number, answer will not change. Like 1 lakh plus 0, that is 1 lakh only. 2 crore plus 0, that is 2 crore only. Or simply 1 plus 0, that is 1 only. So we have the number 0. Okay. So that is the actually additive identity. Additive identity. Why that's the additive identity? As we have discussed, the number 0. If we add in any number, answer will be that number only. Okay. As we have seen here, 5 plus 0 is 5 only. 7 plus 0, that is 7 only. 13 plus 0 is again the 13 only. So there is no change if you add 0 in that number. So additive identity for the addition or additive identity, that is 0. That is 0. Always remember that. It means that if for any number plus 0, that is that number only. Okay. So whenever in the MCQs or in the fill in the blank, if the question is like 5 plus something is equal to 5, it means that is 0. Okay, always remember that. And 0, that is additive identity or identity for addition. Now the next is identity for the multiplication or multiplicative identity. Okay, in both ways we can say. Now from the additive identity, you can identify that which is the multiplicative identity. The process is almost same. Here we were just following the mathematical operations addition one, and here we will follow the multiplication operation. Now let's see. Suppose I just do 13 multiplied by something and answer is 13. Okay, 13 multiplied by something and answer is 13. So here whatever the number will come, that is identity for the multiplication. So here again the same thing. If you do the multiplication with any number, okay, for any number, if you do the multiplication with any number and answer is the same one, it means that is the multiplicative identity. Like 13 multiplied by something and answer is 13. So here the something is the multiplicative identity. Like 1 crore multiplied by something is 1 crore. It means the something number that is multiplicative identity. Here that is in the addition there is 0 only. Okay, if you add any another number like at the place of 0, 1, 2, 3, 4, answer will change. So same thing is here in the multiplication also. There is only one single number. By that, if you multiply any number, answer will not change. Like 13 multiplied by 1. 13 ones are 13. Okay. For any another number, if you will select any another number here, answer will definitely change. There is only and only one possibility for the 13. If you just do the multiplication with the 13 for any number, answer will not change. It will remain as it is. Now the next, let's see, 15 multiplied by 1, that is again the 15. Then 37 multiplied by 1, that is again 37. Or for the larger numbers, if I say that 10,291 multiplied by 1, that is again 10,291 only. Okay. So now we can say that the 1 is the identity for the multiplication or 1 is the multiplicative identity. Fine. So here 1 is identity for multiplication. So this is the very important and very interesting topic for the additive and the multiplicative identity. Okay, hope you understood properly. Now just pause the video and note it down. So let's start exercise 2.2, question number 1. In that we have to do the addition, but we have to do it by suitable rearrangements. Now what is the suitable rearrangement? The addition, that's really very simple, no need to do anything, but how we can make it very easier with the help of the properties. Rearrangement, that is means of the we will use the properties only, but how we will use, let's see. First of all, let's see one example, then we will go for the question. If I just write that 7 plus 2 plus 3, 7 plus 2 plus 3, okay. Now in this one, here simply if we do 7 plus 2 is 9, 9 and 3, that is 12. Okay, so we need to just do the calculation, or we have to calculate like 7 then plus 2, it means 7, 8, 9, then plus 3, it means 10, 11 and 12. Like that we can just identify that. But if I just do a very small rearrangement, then just see how we can do the calculations very easily. If I just write 7 plus 3 plus 2. Now see, 7 and 3, 10, 10 and 2, that is 12. That's really very easy, because what we did, we just converted as the, how we can get the answer 10. Okay, so because 10 plus 7 is 17, 10 plus 9 is 19, 10 plus 2, that's 12. So whenever you add to 10, that's really very easy to do the addition with compared to any other numbers, like 17 plus 5. Okay, 17 plus 5, or if I just ask you that 20 plus 5, that is 25, and 17 plus 5, we need to do calculation. Same thing for the larger numbers. If I just ask you that 230 plus 7, that is 237. But if I ask you that 237 plus 15, at the time again you just need to do the calculations. So the same thing we will follow here. We will find out that how we can get the 10 in the addition. Now here actually the numbers that 837 plus 208 plus 363. All the numbers having the 3 digits. Now can we get 10 over there? No, we cannot. But just remember that at the ones place, if you will get 0, it means that's done. And how we can get 0? If we add the ones places. If we add the ones places, it means here is ones place, that's 7, here is ones place, that's 8, and here is ones place, that's 3. If we just do the addition for the numbers, and if we get answer like 10, 20, 30, then that's very, very easy to do the calculations. Now see here is 7. Here is 8. 7 and 8? No, that's much tougher. Here is 7 and here is 3. 7 and 3, 10. Okay, so that will be really very easy to do the calculation. So here I am just going to rearrange the numbers like 837 plus, now I will write this number. So 363 plus 208. Okay. So here I just did a very small, a very little change. Okay. to make calculations easier. Now, here is 837 plus 363. See here, I am just going to do here. That is 837 plus 363, 7 and 3, 10, 1, 6 and 3, 9 and 1, 10, 0, 1, 8 and 3, or 8 and 1, that is 9, 9 and 3, that is 12. So here we got 1200 for these two numbers. So I can write 1200 plus 208. Okay, now it's really very easy to do the calculations. That is 8, 0, 2 and 2, 4 and 1. So the answer is 1408. 1408. Now here we change the numbers, we shuffle the numbers. So which property we use? Okay, we have already learned that suppose I use 2 plus 3 and 3 plus 2. Answer will be same. That's 5. So which property is this? Shuffle the numbers. That is commutative property. So you can write that which property used here. That is commutative property. So you can write over there. That is commutative property. Okay, so this is how we can do the addition with the help of rearrangement the numbers. Okay, by rearranging the numbers. Now the next one, that is 1962 plus 453 plus 1538 plus 647. Again the same thing, we'll just identify that how can we get the sum, that is 10, or at the unit place how can we get answer 0. Now let's check from the first. 2 plus 3, no. 2 plus 8, yes. So here is one page, that is 1962 and 1538. So simply just write that 1962 plus 1538. Now the remaining number, this one, 453 plus 647. But luckily here, see here, 3 and 7, 10. So we have the two pairs. By that we will get the answers 0 on the unit place. So that will be really very easy to do the addition. Now in the next step, what I have to do, I will just add these two numbers. So 8 and 2, 10. I am just doing the horizontal. If you cannot understand, you can just follow this method like 1962 plus 1538. Okay, in both the way you will get the same answer. But here I am just going to do the horizontally only. 8 and 2, 10, 1 carry, 6 and 3, 9 and 1, 10, 0, 1 carry, 9 and 1, 10 and 5, 15, 1 carry, 1 and 2 and 1, 3. Okay, so answer is 3500 for these two numbers. Still, this 2 is remain. Okay, so plus 7 and 3, 10, 1, 5 and 6 and 4, 10, 1, this is 5 and 6, that is 11. Okay, so here now 3500 plus 1100, just add these two numbers, so that will be 0, 0, 6 and 4. So that is 4600. So our final answer, that is 4600. But now again, which property we used here? That is commutative. So we can write over there, we used property. Okay, that is the commutative property. We just shuffle the numbers. And in the next step, what we did, in the next step, we make the groups. We make the groups. So that is again the associative property. So this is how we can use the properties in the different mathematical operations. Okay, now just pause the video and note it down. Now the question number 2. In that we have to do multiplication, but how we will do? As we did in the question number 1, okay, with the help of suitable arrangements. By the arranging the sequences, how we will do? First of all, see the A1, that is 2 multiplied by 1768 multiplied by 50. Okay, so before we do that, let's understand one example. Like if I just ask you that 5 multiplied by 8 multiplied by 2. Okay, so that will be like 5 8s, that is 14 multiplied by 2. We have to follow this process. But apart of that, if I just do a very small change like 5 multiplied by 2 multiplied by 8, okay, I just shuffle these two numbers. Fine. Now 5 2s are 10, 10 8s are 80. How easy it is? See, that's really simple to do the calculation by doing a very small rearrangements. Okay, and what we did and why we did the rearrangements, now see here. I just tried to find out like 10, 100 or 20, 30 by the tens. Okay, all the tens. So find out tens always. Okay, in the multiplications. It will help you to make calculations very easy. Let's start with the question number 8. Okay, here that is 2 multiplied by 1768 multiplied by 50. If I simply just do the multiplication of these two numbers, I will not find any tens. Tens it means, okay, the 0 at the last, 0 in the ones place, fine. Now, here that's not possible. Now here, 2 and 50, yes, that's possible. So, I will just shuffle the numbers, 2 multiplied by 50 multiplied by 1768. Okay. Now, 2 multiplied by 50 is 100 multiplied by 1768 as it is, and 100 multiplied by 1768 like 7 multiplied by 10, that is 70. Then 15 multiplied by 100, that is 1500. It's very easy to do the multiplication of any number with 10, 100, 1000 like that. Okay. So here we have 100. So what we will do? Simply we will write the number as it is 1768. And how many zeros are there in 100? 2. So put the 2 zeros over there. So that is your answer. So our answer is 1,76,800. Okay. So this is the really very easy method to do the multiplication with the help of proper rearrangements. Now the B1. Okay. So again we'll try to find the tens place on the tenses on the unit place. How we can do? See here. 4 multiplied by this number, no, there is no any option because 4 6 that is 24. So we cannot do that. Now 4 5 that is 20. It means 0 will be there in the unit place. So let's shuffle these two numbers. Okay. So 4 multiplied by 25 multiplied by 166. 4 multiplied by 25, that is 25 4 is 100. So 100 multiplied by 166. Answer will be 16600. Okay. So answer is 16,600. Next one, that is 8 multiplied by 291 multiplied by 125. Again, just find the zeros in the answer. 8 ones are 8. No, there is no 0. Now 8 5s are 40. Yes, 0 is there in the unit place. So let's shuffle the numbers. 8 multiplied by, first of all we will write this number, so 125 multiplied by 291. Now 8 multiplied by 125, let's do the multiplication. 8 5 is 40, 4 carry, now 8 to the 16, 16 and 4 20, 0, 2, 8 1 is 8 and 2, 10. So here we got answer the 1000 multiplied by 291. So answer will be 291 and 3 zeros from 1000. So answer is 2,91,000. 2,91,000. Here, in each and every questions we used the property that is commutative property. For the multiplication, okay, for the multiplication, because the properties can be used for addition, multiplication, division, and subtraction for all the operations. But here we use for the multiplication. Okay, hope you understood properly. Just pause the video and note it down. Now the D1, that is 625 multiplied by 279 plus 16. Okay, so again we have to do the first of all suitable arrangements and then we will do the calculation. So let's start here. So as I told you, first of all we will find that how we can get the zeros. Okay, so here is 5, here is 5. So by that I can get the zeros. But how? First of all, here is the number 16. Now 5 and 6, 6 5s are 30. So that is possible. Now let's check for another number also. Here is 9. 9 5s are, that is 45, and 9 6s are, that is 50. 9 6s are, that is 54. So that's not possible. So first of all, we will just multiply these two numbers. It means we have to rearrange the numbers. So here, what I will do, 625 multiplied by 16 multiplied by 279. So here, which property we used? Here we can write that here we used the commutative property. Now, if you want to use the associative property here, you can use. But for that, what we'll do? Simply, in the associative property, we have to make the groups. So how we will do? First of all, make the group for these two numbers. That is 625 multiplied by 16 multiplied by 279. So whenever you make the group for two numbers or three numbers, okay, that is the associative property. So here I used the associative property. Okay, so this is the something about the properties. Commutative each and every time we were using, but we didn't use the associative property. So for your reference only I used here, but that's not actually necessary, because whenever you use the commutative, so here is the pair, that is 625 multiplied by 16. So first of all, we will multiply that two numbers only. So here is the brackets. Always first of all solve the brackets. So I am just going to the multiplication over here. 625 multiplied by 16. So let's do here. Okay, let's start with the 6. 6 5 is 30, 0, 3, 6 2 is 12 and 3, 15, 5, 1, 6 6 is 36 and 1, that is 37. Now here is 1. Okay, after 1, how many digits are there? 1 digit. So put a 1 0. Now simply 1 5 is 5, 2 and 6. Now just add this 0 and 0, 0, 5 and 5, 10, 1, 10, 1 and 10. Okay, so answer, that is 10,000. That is 10,000. So here just write that 10,000 multiplied by 279. So now 279 as it is. And how many zeros are there? 4 zeros. So 1, 2, 3, 4. Okay. So this method you can use only whenever the given is like 10, 100, 1,000, 10,000, 1 lakh, 1 crore, 10 crore, like that only. Okay. Suppose there is 2 lakh, then you cannot use this method. First of all, you have to multiply 2 multiplied by 279, then you will just place the zeros, that's fine. But whenever 1 is there, you can use that method. Okay. Now, the E1, that is 285 multiplied by 5 multiplied by 60. So here, again, let's check. 5 5 is 25, not possible. 5 into 0, yes, that is possible. So, there is no need to do any further changes. Simply, I can start like 285 multiply that. 5 into 6, 30. 5 6 are 30 and 1 0. Now, 285 multiplied by 300. So simply, I am just going to multiply with 3 only. Okay, not with the zeros. Zeros will put in directly in the answer. So here, 3 5 are 15. 1. 3 8 are 24 and 1 25. So 2 carry. 3 2 are 6 and 2 8. And 2 zeros are there. Put 2 zeros. 85,500. That's the answer. Again, here we did not use any property, but we can say that we use the associative. If you just do the bracket over there, so that will be the associative property. That is the small arrangement we can use. Now F1. Okay, in that 125 multiplied by 40 multiplied by 8 multiplied by 25. There are actually 4 different numbers. So let's see how we can do. 125 multiplied by 8, that is 1000. We remember that because in the question number 2 or 3 something we found that. So simply I can go and I am going to make a group of 125 multiplied by 8 and now 40 multiplied by 25. Okay. So here we have the groups. So which property we used? Commutative as well as associative. Commutative as well as associative. First of all, I just shuffle the numbers, so that is the commutative property. And after that, at last, I just make the groups, so that is associative property. So here you have to write that commutative and associative property. So I am just going to write that commutative and associative property, which we used over there. Now simply just do the multiplication. 25 multiplied by 8, 125 multiplied by 8, that is 1000 multiply by, okay, here is the 40 and 25. 25 fours are, that is 100 and one more zero, just put it there. 1000 to 1000, simply 1 ones are 1 and just count the total zeros. How many zeros are there? 3 and 3, total 6 zeros are there. Put the 6 zeros. 1, 2, 3, 4, 5 and 6 plus the commas according to Indian number system always. Okay, so the answer that is 10 lakh. Fine. So hope you understood. Now here the question number 2 is completed. Okay, now just pause the video and note it down.